Hello, everyone, and welcome to the latest episode in our virtual event series covering the electrification of private and public sector fleets. I'm Alana Weitzman, Vice President of Strategic Development, Clean Transportation at Electric Autonomy, and I'm excited to introduce this installment in the EV Fleets Pro virtual event series, Powering Smarter Fleets, How Managed Charging Cuts Costs and Boosts Reliability. Before we dive into today's discussion, I'd like to thank our partners for supporting today's session. Take Charge offers a variety of business rebates aimed at improving energy efficiency and reducing electricity costs for businesses in Newfoundland and Labrador. If your business has a commercial account, you may be eligible for an incentive. And I want to just go through some of their key offerings. Product rebates, so you can receive rebates on energy efficient products such as LED lighting, thermostats, heat pumps, and more. Custom solutions, including tailored energy efficient upgrades of up to $50,000 are available, along with savings tips and guidance on how businesses can save energy and reduce electricity costs. Make sure you contact takechargenl.ca before starting your next project to see how they can help. Take Charge is now also offering the EV Fleets Learning Program, and I'd encourage you to register if you haven't already completed this free digital course. I also want to thank Polara, a leading electric vehicle infrastructure and software company that partners with fleet operators throughout the entire electrification journey, from designing charging infrastructure to dynamically managing charging operations. They deliver tailored charging solutions, empowering customers to optimize their energy transition while unlocking new revenue streams. And we'll talk about that more today. I want to highlight that the experts behind the Cleo by Polara platform have also helped us build a new lesson topic for our EV Fleets learning course, getting the most from managed charging, and we really appreciate them sharing their expertise. Before we get started, I'll take a moment to acknowledge that our work at Electric Autonomy is conducted from the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. I'm now very happy to introduce you to our expert panel today. They are Jacob Rodgers, Manager Regional Engineering and Projects at Newfoundland Power, Stéphane Belair, VP Product and Engineering at Cleo by Polara, and Santi Spencer, Senior Data Scientist, Insights and Integration Consultancy at Geotab. Now, we would also love to hear your questions. The best way to get a question to us is to use the Q&A box in the bottom right of your screen, and we will get to as many of them as we can. If you're not asking a question, you can also add a comment in the chat box, and we really encourage you to engage with other attendees during the session. And now on to the topic at hand. So I'm going to start by asking Jacob for a bit of an explainer. Once you have more than a couple of vehicles charging at a single site, like a fleet of municipal or technician vehicles, what kind of challenges does that present from a utility and power perspective?
Thanks for kicking us off with that one. That's certainly a great segue and really great point to start us off here. From both the utility and the business perspective, it's really sort of the same challenges and same problems, sort of looking at it from a different lens. At its core, it's the overall demand on the electrical service is really the core function. From the utility perspective, while one individual business having a increase in demand might not seem like a huge piece to it, of the tens of thousands, hundreds of thousands, millions of customers served by an electric utility. However, what the customer may not understand from that side is there may be system constraints on the utility side of things. So as EVs are becoming more and more cost effective and companies are looking at electrifying their fleet, it's sort of everyone looking at these sort of options at the same time could all of a sudden mean 2, 3, 4, 10, 20, hundreds of businesses at the same time adding, you know, bits and pieces to their electrical load on their system, and all of a sudden becomes an overall larger system problem for the utility of we don't have enough generation to supply this. The distribution lines serving the area aren't big enough, the transformers serving the areas aren't big enough. And if not, if the utility isn't given enough leeway, could all of a sudden be faced with um, very costly utility upgrades that aren't able to be managed because we weren't able to plan ahead and sort of look at things on the horizon. From the business perspective, these commercial customers have their kilowatt hour charges, so their energy that they're using, they're going to be charged for those. So obviously, that's going to increase. But working around managing your charging is also going to impact that demand charges on your bill. So your kilowatts or your kVA demand charge on your bill. That if you're now all of a sudden adding this large electrical load to your demand, if things aren't managed timed correctly, all of a sudden that demand could go on top of your existing electrical demand for your service in your building, and all of a sudden now seeing a larger demand charge on your service was really a key factor for trying to manage um, those demands on your overall electrical system. And depending on the size of it, could also result in further electrical upgrades beyond just those required to install the chargers.
Yeah, and Jacob, I remember you sort of explaining to this even down to if you think about it on a daily level, as your commercial loads on the utility system used to happen during the day, and then everyone went home and cooked at night. But we know that fleets charge overnight, and so this becomes kind of another compression point. It would be great to sort of have you chat about that a bit.
Yeah, and that's a great point, and thanks for the reminder that our normal loads, from a utility perspective, businesses are typically Monday to Friday, 8 to 4, 9 to 5. And so we see people's loads in the residential homes start to taper down after that sort of morning window around 8 a.m. or so as people are getting to work. And then loads from the residential taper off and the commercial pick up a little throughout the day. But then as people go home to cook a meal, to do laundry, turn on their dryer, turn their heaters back on, and the residential loads start to creep up again, you normally have that drop off of those commercial offices Monday to Friday, 9 to 5 style businesses. But now with those businesses going and charging their fleet of vehicles 5 o'clock, people going home and charging their vehicles at 5 o'clock is all of a sudden adding this extra demand on the utility system that, yeah, we're used to seeing a normal bump from 5 to 6 7 p.m. in the evening, but now all of a sudden that's going to be a much larger peak because we now have these heavy electrical loads all coming onto our system at the one time because everyone is plug my vehicle in when I leave work, and 10, 20, 30 minutes later, I get home and I plug in my electric vehicle at home. And without any managed charging, all of a sudden we're driving up a much higher peak on the electrical system. And then the utilities are having to invest in larger transformers, more generation to add to the system to be able to meet that peak demand, even though even though the overall consumption may not change because if we were able to manage it, we're able to sort of flatten that peak out, flatten out the curve, and manage that load and manage to supply that electricity with smaller levels of upgrades or potentially even no upgrades depending on how big of a bump you're seeing in terms of electrical demand.
Yeah, that's great. And Stéphane, I guess that's what energy management software is trying to solve. So it'd be great to hear from you at its most basic level. How does this work? And then if you have a fleet where you can sort of almost give us a little bit of a case study of how this has had an impact for them, that would be super.
Sure. So basically, a smart charging platform sits at the intersection of the vehicle, the charging infrastructure, and the operational needs for that vehicle. So basically, the duty cycle. So the most advanced smart charging platform will be able to create a charging plans for every vehicle in the fleet. So basically, what does that mean is that the driver can just, plug the vehicle, and the system will know exactly when to charge that vehicle for how long, so it's ready for the next duty cycle for that vehicle, and it will auto prioritize basically the charging. It's going to be able also to use different strategies to help what Jacob was explaining. So we can for sure do peak shaving, so reduce the maximum power at a specific site to charge all the vehicles. And we can also shift basically the power outside of the hours in terms of consumption, and basically move that power outside of it's basically called demand response in that sense. So charging basically overnight instead of when the driver connects the vehicle directly at 5 p.m. when there's a high demand on the for the utility. And when we're looking at what a smart charging platform can do for operators, we have several case studies that were able, depending on the duty cycle of the vehicle, were able to shave up to 70% of that peak power per month. And that's very, very helpful in what Jacob was explaining from a utility perspective, but also reducing the cost of energy to charge those vehicles and be competitive for the operators.
That's great. I'm actually going to grab a technical question that was asked during the registration process to follow up here. Someone from our audience has asked, is the load management that you're talking about done via the cloud or locally? And is it just scheduled or active depending on demand?
Very, very good question. So it can be done purely in the cloud, and we connect to the charger via a cloud connection, or we can have a smart controller at the site to take those decisions, depending on, what's the configuration, what's the site needs, and the infrastructure currently used to charge the vehicles. So we can adapt to many different use cases. Is it done automatically? Is it done static? It depends on the smart charging platform that you're going to be using. Most advanced will be fully automatic. So you connect the vehicle and the charging plans will be applied to that vehicle through the charging infrastructure, and it's really a plug and play experience. Other smart charging platform will set static points that it's a little bit less dynamic, but can also solve some of those problems as well.
So we've talked a little bit about once the charging infrastructure is, being actively managed on a site, but also when we're thinking about some of the things that Jacob said about, how much power do you think you need, and how do we actually right size charging infrastructure on a site even before it gets built? Can this kind of technology help fleets do a better job of calculating what they're actually going to need, rather than just, going for the peak of all vehicles charging at the same time versus in sequence? So I'm going to start with Santi to jump in on that one.
Thank you so much, Alana. Thank you so much for having me. So for us, data, and in this case specifically telematics, is crucial for informed decision making in this space. And just to introduce Geotab for those who may not know, Geotab is the global leader in telematics. We're a Canadian company with over 25 years of experience in the industry, and with over 4 million subs worldwide and 80 billion data points processed daily. We really do live and breathe data, and we like to say that you can't manage what you don't measure, and data really is at the heart of that. So we've highlighted the importance of data and telematics data in this process of electrification. And for us, we see telematics being crucial throughout that entire journey, from the start, from planning the charging infrastructure stage, where telematics data is key if you want to avoid making those decisions and pitfalls that can potentially cost more money and time down the line. Those things that Jacob alluded to, like wrong sizing, choosing the wrong ratio of charger to electric vehicle, charger to electric vehicle, choosing, as you mentioned, the fastest, the most powerful charger that may be too costly for your operations. Getting that information from the utility is really important in planning that charging infrastructure along with the utility. As well, all the way to operating that electric fleet and dealing with the challenges of making sure your EVs are ready to perform their tasks for the day, preventing that downtime, preventing undercharged vehicles, and developing that charge management strategy. Really imagine making all these decisions throughout that entire electrification journey without the intel that telematics provides. So really think it's crucial to understand your electric vehicle duty cycles to not only right size your charging infrastructure, but also be able to operate thereafter.
Jacob, I wonder if you can weigh in as well. When you get fleets requesting megawatts, are you seeing that they've taken smart charging into account? Are they looking at that data that Santi is referring to, or are they just asking for sort of what they think is kind of the maximum power they're going to need at the site? And what do you wish fleets were thinking about?
Yeah, it's a great question. Quite often from the utility perspective, we'll see the customers asking for the maximum that they think they could need, the maximum that things are designed to carry, because there's some concern around if we don't ask for it, it might not be available and we might need it. Some of that hesitance around this is new, not really sure what I need to do, not really sure how we're going to manage this, but need to make sure that the utility has capacity for us and has capacity to do this. And what that can result in is that can often result in electrical services, transformers, distribution system upgrades all being oversized and end up costing the utility, which results in all the ratepayers, but also whatever contribution provided from the customer could be more than was actually necessary. And that's where smart fleet management and smart charging can really come into play to say, yes, we need X number of chargers, but the way the fleet working and some of the stuff that Santi is saying there around the telematics from Geotab can really help form to say, okay, maybe not every vehicle needs to be charged every night. Or what Stéphane's saying about the planned and the smart charging is when it's charging can help really manage possibly getting all the vehicles charged throughout the off hours and outside of the normal duty cycle without all of them having to charge at the exact same time. So you could end up twice as many vehicles charged for the same amount of overall electrical demand and just spreading out the kilowatt hours as opposed to doubling the demand and getting all the vehicles done and they may be charged, 1 or 2 o'clock in the morning and then just sitting on the chargers, not consuming anything, where you could have spread that out and overall reduced your demand on the system, which could at the end of the day save on those costly upgrades. So really, from the utilities perspective, what we'd like to see is get us involved early, get the utility and get partners involved early in the planning stages so we can talk through some of these options, so we can identify potential constraints. It could easily be possible to say, if up to, maybe it's a half a megawatt, there's no upgrades required from the utility, but if you go above that, there's upgrades required. And that's something that a customer could say, okay, well, that's a constraint. Let's work to that. Maybe smart charging and my telematics, my data could help me stay below that threshold. And then I don't need any upgrades and I'm able to, service those without additional upgrades from the utility, because knowing then I'm going to have to buy the chargers, I'm going to have to buy the vehicles, it's already going to be a costly endeavor. If there's options to minimize the required investments from the utility, well, that's going to be savings at the end of the day. So biggest thing I can say, and I'm sure it won't be the last time I say it here today, is get the utility involved early in the planning stage so we can help be a successful project at the end of the day.
Yeah, absolutely. And we hear that time and time again, that it is the best plan is to get your sort of expert team involved very early in your fleet electrification process. So, whether that is tapping into, a charging infrastructure provider like Polara, with, the intelligence of Cleo, or that's Geotab, or that's some other partners like 7Gen that we've had on previous webinars. I really do encourage you to find that kind of expert team. And that expert team also does include the utility. They have, fantastic advice, and, kind of in a way that's sort of the best path forward. And so the other thing I think is that all of this is really tailored to the operations of the fleet. So I want to kind of bring that into how this technology really supports those operations, and how, fleet vehicles have, different routing. They have fluctuations in temperature depending on where they are in the country. All these things that kind of affect range, and range impacts how much power you need stored in the battery, which means how many electrons you're going to be asking Jacob and his team for. So I wonder if we can kind of talk about how smart charging can make fleets even smarter in their operations. Stéphane, I'll start with you.
Thanks. There's a big difference, a big gap between, let's say, the initial fleet study and doing the operation day to day of your fleet. And smart charging needs to understand that duty cycle that we've been talking about. This is a key component. Smart charging will have roughly three big ways of understanding the duty cycle to be able to optimize the charging plans for the vehicles. First, you will have probably in your platform a way to enter the routes of the system and a scheduling system. So you can put like, okay, this vehicle is leaving at 9 a.m., it's going to be returning at 5 p.m., it's going to do that, that many kilometers. And the system will know how much time it has to charge, what's the energy need, but it's very static and it's very, very hard to maintain. And you need to have someone in your organization that will do the data entry and make sure that is always accurate for the system to do the optimization that it needs to do. Other system will connect to transport management system. So you need to build an integration with those platforms and it will bring the data automatically. This is a very, very good option. You need to make sure that your systems are open and can connect and can talk to each other. And what we've done at Cleo, because not everyone has a TMS system that can integrate and they don't have the people in their organization to do the data entry. So we've come up with a unique method of understanding and learning the duty cycle of the vehicle based on the telematics of Geotab. So Santi was mentioning, how telematics is very important for the duty cycle. So we're basically leveraging the data that we're gathering from Geotab, and we're able to understand and learn the duty cycle of the vehicle automatically. And we can predict basically that vehicle will be leaving tomorrow at that specific time, will be returning the number of kilometers. We can also predict the energy needs, and we can correlate with the weather because, as you mentioned, weather has a big impact on the range often. So we can put all the data together and optimize based on those predictions. And it's very, very, it's been proven to be very effective and very dynamic in terms of on the operations side of things. It's very resilient.
Santi, I don't know if you want to weigh in here as well on how this kind of digitization can really help a fleet with operations, especially when they're electrifying.
Yeah, absolutely. I'll just piggyback off of what Stéphane mentioned about the importance of really understanding that duty cycle and understanding what your electric vehicle requirements will be in terms of energy. Taking the telematics data from your internal combustion fleet to model that potential energy requirements, that's something that this type of technology is able to do. Stéphane mentioned overlaying different factors of region and temperature to really understand the impacts on that range. That's something that we see partners really using sort of our telematics data as a foundation and then really augmenting it. Something that we also do ourselves with our electric range that we provide our customers and battery capacity estimates. But it's great to see other partners also sort of use our data to get to those insights as well.
And so, when all of this is done well, it's going to not only produce a reliable fleet, but it's also going to save fleets money. So I think we should talk about it a little bit. Jacob, I'm going to turn to you. How does this software save a fleet money? We talked a little bit about peak shaving and those kinds of activities, but it would be great to really sort of just go over that again so people really understand the financial impact this kind of software can have on reducing what I would call their fueling costs.
Yeah, for sure. It's a great point, and I don't think we can focus on it really enough. There's sort of a few key components to a consumer's electrical bill. Obviously, you have your kilowatt hours, your energy that is consumed. And the more energy you consume, there's a rate per kilowatt hour. Depending on your jurisdiction, there may or may not be time of use rates. Those time of use rates, if using smart charging, may allow you to shift may allow you to shift your load outside of peak times, which can help peak shaving, but that may also put you into a window where the kilowatt hours are actually cheaper for you as a utility customer at the end of the day. So depending on your jurisdiction, there may be time of use rates available. Commercial customers typically have a demand charge on their bill, so their kVA or their kilowatt demand. That managed charging can allow that to shift well outside of your normal operating hours. So if you're a 9 to 5 business, but a lot of your fleet returns at 3 o'clock and all start plugging in their vehicles at 3 o'clock, and without managed charging, all of a sudden you have your normal building loads on, which is what your demand charge is used to, and then you might add 3 or 4 or 500 kilowatts to that by plugging in a full fleet of vehicles. So managing that can help lower that charge, which is another charge on your monthly utility bill. And then finally, the potential upgrades from a utility perspective coming in, as I said previously, with unmanaged charging, the utility is going to have to assume from the upgrades that it's all this could go on normal building loads. So now all of a sudden your building was a 1 megawatt building. Wires going into the building were sized for that. The transformer was sized for that. The distribution system leading up to your building has been planned for that. Now you're adding a megawatt of charges. Now all of a sudden it's 2 megawatts. So it's conductor upgrades, it's transformer upgrades. It could be larger distribution system upgrades. Whereas if we see, hey, there's a managed system in this, and that's actually not going to change the demand of that service overall, the utility may be able to take a step back and say, okay, well, this is new, but for now, it's probably something we can just monitor. But right now, if they are able to charge like they say they can, we might not need to do any upgrades at all, and therefore not need to look for any contribution from the specific customer to complete said upgrades.
That's great. So this nice little software layer means that there's a sort of it offsets that investment in the hard stuff, the expensive stuff. Absolutely. Stéphane, we're talking about cost. It would be great for you to speak a little bit to what you're seeing with clients, but there's the other side of it, which is that the cool thing about EVs is that when you fuel them, you can actually generate revenue versus a fossil fuel consuming vehicle where you are just sort of pumping and then burning, and there's kind of no benefit. So it would be great to understand the potential there.
Yeah, sure. It's often not, operators, it's new to them, so they need to understand how they can monetize their energy assets, because vehicles can be considered as energy asset. And we're going to be moving in a world where V2G will be more mainstream than what it is currently today. But today you can still monetize your infrastructure first by doing smart charging and reducing up to 70% of the peak power, and it's going to reduce your energy costs. So that's probably the first thing to do. After that, you can look at, okay, is there my local utility can I participate into demand response program? So you will have a compensation for every kilowatt that you're not consuming during those time. So that's another way to bring revenue, or to monetize your infrastructure and your vehicles. And finally, it's the carbon credits. And every vehicles will generate carbon compliance units that you can trade. And there's companies, and Cleo and Polara, we have our own internal programs. It's really a turnkey program to all the way up from, charging your vehicle, optimizing the charging, participating in program such as demand response. And finally, we have the carbon credit that we can monetize as well. So and it's going to be improving in the future. There's going to be more programs, more rates. It's just the beginning for most of the operators, but there's options today that we can leverage.
One sort of last question that I think is really important to ask, and I'll sort of address it to you, Stéphane, while you're still on camera, is that, as we look to digitize these fleets, there's a lot of data, as Santi mentioned, sort of pouring through these systems. everything from the state of charge of a vehicle to its routing. And I guess the question fleets might have is like, oh, is this creating a vulnerability? You know, how do we make sure that this kind of critical infrastructure is not open to cyber attacks? How do we make sure our data is safe and sound and isn't being tapped into by competitors or by anyone else? So I think it's important to speak to that.
Yep. Every time we have data going through different platforms, we need to make sure that this full end-to-end chain is secure. It starts with usually the charger, making sure that the chargers support, let's say, one of the big protocols, open protocols that most of the chargers are supporting today, it's OCPP, making sure that it uses the latest security option in that OCPP integration. So that's first thing. After, you need to look at your smart charging platform. It's going to host, it's going to store all your data. So making sure that your platform has, once again, standards such as SOC 2. It's a very well-known security standard. ISO 27001 is another great one. So making sure that they are audited, they are following best practice in terms of cybersecurity, that your data is stored in the region where you operate. So data residency is another big thing. And we need to think about charging infrastructure as critical infrastructure. Imagine someone entering your infrastructure and just turning down all your charger at the same time. It can be very critical for an organization to protect not only the data, but the operation of charging.
That's great. Okay, so on to our audience questions, and thanks to everyone for your questions that you've been asking today and in the registration process. I'm going to start with, how do we tackle the cold battery issue? So for everyone out there, that means in layman's terms that because of chemistry in very cold weather, batteries aren't going to be able to provide as much range from, let's call it, a very cold start, or even, you know, through the course of the day. So you know, as this person has asked, we need some real data on battery power, ambient air temperature, and kilometers available. Santi, I'm going to start with you to sort of jump in on the data that Geotab's seen on the effect of cold weather, and then we'll get to how smart charging can help with this.
Yeah, absolutely. So yeah, we do have a host of data related to this topic in terms of analyzing the effects of cold weather and temperature on battery performance. Anecdotally, we see anywhere from 10 to 20% reduction, and something that really needs to be considered when you're sort of implementing your charging plans and considering your duty cycles for your vehicles. So having that data to understand the impacts so that you can actually make those informed decisions so you don't have any potential downtime, that's really key in this space. So having a large data lake like we have, I mentioned 80 billion data points processed daily. We pull from that and pull insights from all our electric vehicles that are connected to really understand those impacts.
That's great. And Stéphane, I wonder if you can chat a little bit about how we can get vehicles ready for the day and help with that sluggish chemistry.
Like Santi was mentioning, it all starts by, charging accordingly based on the weather. So that's one thing. But another thing, it's basically preconditioning of the vehicle in the morning, making sure that the vehicle is heated, the battery is up and running at the right temperature, and a smart charging platform will be able to making sure that the charging session is still available for the vehicles, so the vehicle will consume the energy from the charger, from the grid, and not from the internal battery when it's doing preconditioning. So it's something that you can set up inside your smart charging platform to make sure that your vehicle is ready, full warmed, and they're ready to go.
That's great. So I think a lot of folks are really interested in some of the deployments you've done. So I have a question here. While in theory, charging software can handle large numbers of vehicles, what has the panel seen in real life as, we're at the start of fleet electrification?
Maybe I can start with this one. We're seeing customer with one or two vehicle up to hundreds of vehicle. For me, I think my recommendation it would be to start early with smart charging because it brings different concepts. It's going to help you, first of all, just managing the charging operations. You'll be able to see, what's the state of charge of your vehicle, what's the charging sessions, understand how electrification work for your specific use cases. And then we're going to be able to optimize for sure when we have, one vehicle, one charger, or two vehicle, two chargers. We can for sure optimize. We can do peak shaving and I would say basic optimization. And it's going to be helpful, but really start early. There's no threshold of vehicle or charger to start do smart charging. Just you have one vehicle, let's start.
That's super. Anyone else want to weigh in?
I just want to say I myself, I focus more on the sort of the planning, infrastructure, and electrification procurement stage, so not the scaling section. But I know our marketing department works hard to put out case studies for fleets that are scaling. So be on the lookout for those types of blog posts and press releases as more fleets start scaling electric.
That's great. And Jacob, I'm going to follow up with a question here. And I'm not sure how many fleet deployments have sort of hit this barrier yet in your territory, but can you share some success stories of barrier mitigation using managed charging? And I think what that means is where a fleet has asked for a certain capacity, you've looked at it and you've gone, oh, I don't know if we can do that, but where managed charging has been kind of a path forward.
Yeah, so in our jurisdiction, it's definitely still in its infancy. I would say, Newfoundland as a whole is sort of lagging behind a lot of the other provinces, even when it comes to EV adoption. There's been a lot of hesitance in our province. Our province tends to be very vastly populated, a large province, but spread out a lot. So there's been a lot of hesitance there. But there's a lot of conversations going on at the municipal levels, at some of those. We had an event last year where a lot of municipalities were together talking about EV electrification, and they're doing sort of exactly what Santi and Stéphane have been talking about. That they're starting, and they're looking at those smart charging and managed charging there now. Well, we haven't really seen it um, in our jurisdiction quite yet. We're seeing the municipalities thinking about it because they know through experience of trying to even do electrical building upgrades, that they know through those experiences that if they don't try and manage their load, things are going to be much more costly for them at the end of the day.
Yeah, that's great. Stéphane, I don't know if you have any case studies where that's been the case, where you've looked at a site and you said, hey, with managed charging, we can kind of help this fleet.
Yeah. So let's say the infrastructure needs an upgrade. Upgrade takes time, take money sometimes, and depending on the timeline of the project, we can manage what we call it's oversubscription. So basically, and it all depends on the utility and the code. There's very different aspect. It needs to be looked on a case by case basis. But a smart charging can basically limit the power and the charger to not go above what the infrastructure can support. So we can do that. Usually it's going to be a temporary solution. But yes, it's possible to have the software to control and adapt to what the infrastructure can support at that specific time.
We have a question here, which I'm hoping everybody can weigh in on, because none of you are specifically on the charging hardware side. What do you look for and what stands out to you about different charging hardware manufacturers Are some easier to plug into with the software? And also the same question, what about the vehicles?
For the charger, maybe I can start. First, needs to be a smart one, so can be integrated. Supporting OCPP is one of the main standard. Other charger will have APIs, open APIs that we can connect with, so that's good. So first of all, making sure it's an intelligent charger. Then look at what kind of support that you're gonna have locally. Look if they have a good track record. If it's suited to your operations, your conditions, the weather condition, making sure it will sustain your operations on a day-to-day basis. That for me, that's the basic. And for sure, we mentioned security, making sure it's a secure charger as well.
Yeah, and on the vehicle side, I'll add a little bit there. So for electric vehicles, there's a little bit of a challenge just because across the industry, there's a lack of standardization of vehicle signals. So it presents a bit of a challenge in terms of getting to those data signals, understanding the data, and there's a bit of work that has to be done in terms of reverse engineering or having those relationships with those manufacturers to ensure that those are maintained correctly. So when you're thinking about electric vehicle procurement, and you're thinking about how you're going to use the data from those electric vehicles to make informed decisions, I think it's also always important to understand whether that electric vehicle is supported by whatever telematics provider you decide to choose. It's really important because, again, there's not really a standardization of those electric vehicle signals. So whatever telematics provider you choose has to have sort of the acumen to be able to decode that those signals. And yeah, Geotab, just to put it out there, we support over 300 different EV models and leading the industry in that. So make sure that you get the data from the electric vehicles is really what I'm trying to say.
Yeah, absolutely. I think fleets sometimes underestimate the importance of the interoperability of all these systems. And again, having folks who are advising you or working with you who can keep this sort of knitted from a vehicle software through to a charging software through to all the software that stacks on top of those systems, keeping them sort of working seamlessly is really important. Stéphane, back to you. I've got a question here. Is there a minimum power demand, example, 1 megawatt, where the ROI of this managed charging system breaks even?
It depends on I would say the business model of the smart charging. Usually you will find a smart charging platform as it's a SaaS service, so software as a service. It's a monthly fee, usually on the charger. So it's very linear, the ROI. And you can start, with 2 charger to have a positive ROI with a smart charging platform. And it's pretty much linear when you add chargers. Since there is no big upfront cost, that's why it's mainly linear in terms of ROI.
Well, that's very good news. And kind of in the same vein, Jacob, I'm going to ask you a question where someone's sort of asking the best way if you're thinking of, a sizable fleet electrification. And I think when you're talking about municipalities, often this is sort of a really big plan. Is it better to go with like a master plan approach where you have one major upgrade and it's sort of like, okay, by 2050, we're predicting this mega load, let's just go all in and get that done? Or would you say there's value in taking an incremental approach, going after sort of lowest hanging fruit and potentially even sort of stepping up the upgrades that you need from there?
Yeah, so from the utilities perspective, it's sort of a middle point. It's a combination of both. We want to know your master plan. We want to know what your overall plans are for a facility. We want to know what you're going to be doing, so we can take that into consideration. But from a commercial business looking to electrify, it's going to be sort of that crawl, walk, run approach where you're going to get your feet wet. You're going to get a couple electric vehicles. You're probably going to put a couple chargers in, and probably not going to be any electrical upgrade besides adding a new circuit into the panel. Then it's going to say, okay, well, that works for these vehicles. Let's do all of those vehicles in our fleet. And then that might be a bit more, and it's sort of and then get to hopefully electrify everything, and then it's much bigger. So sort of getting those low hanging fruit at first, but if the utility at any point needs to do an upgrade, we really need to know about your total plans, because it's going to be least cost for everybody for us to go and do the upgrades that we can accommodate at one time. So that if you're doing a service upgrade now, that we say, okay, yeah, it might, you're looking for 1 megawatt of total load, but you're also saying you're going to be looking for another, in the next 5 years, you're going to be looking for another, 500 kilowatts, and 5 years after that, you're going to another 500 kilowatts. For the utility, probably going to be least cost from our perspective to know all that up front and say, okay, well, let's just put the 2 MVA transformer there now, and then and put all of our conductors to design for the 2 MVA. That way we have the capacity there. It's done. We're not going to do upgrades for 1 MVA and then go back 5 years later and do more, and back 5 years later and do more. So it's good for us to know that, so that we can sort of, when it hits the point of having to do something, that we can try to account for, if it makes sense from a cost perspective, we're going to try to account for everything when we do the upgrades once, because that's what's going to be least cost for the customer and going to be least cost for us at the end of the day.
That's super. Well, with that, I'm going to wrap up the Q&A for today's session. Jacob, Stéphane, and Santi, a huge thanks to all of you for sharing your insights and your knowledge with our audience today. And thanks as well to you in the audience for all of the excellent questions that took the conversation further. Again, I'm going to thank everyone at Newfoundland Power and Cleo for being such great partners in the EV Fleets Pro program. And I also want to tell you about some great in-person events we have coming up on the calendar. First is our Kilowatt Hour Summit. And this one is really focused on the opportunities and innovation for the electrical grid as we electrify transportation. It is on May 13th at Hotel X in Toronto. And so if you are in the utility sector, government, regulators, or technology providers, this could be a great opportunity to chat about grid innovation and modernization. And just after that event, we have our EV and Charging Expo, which I hope many of you have attended in the past. We'd love to see you this year. And this is a large event at the Enercare Center in Toronto, where we are really looking to power your EV transition, whether you are a fleet looking to electrify, or you are a property developer looking to provide EV charging infrastructure to your residents. We try to sort of deliver great expertise across 2 days of conference programming. There are fantastic commercial electric vehicle test drives available, and a really giant exhibit hall where you can meet sort of the best in class suppliers to help with your EV transition. So I want to thank everyone for being here with us today, and I really do hope to see all of you in person at one of Electric Autonomy's events in May.